Okay guys, today we're going to talk about the Big Bang Theory and galaxies. We're going to look at how the theory is a theory and not a law. And then we're going to try to talk about how we started our universe in the beginnings and how we got to where we are now. So the first thing we're going to look at is the Big Bang Theory itself. This theory states that the universe began in a single explosion out in space. So at first it was all dark, and then all of a sudden, and everything just happened. Scientists have come up with this theory that it happened about 15 billion years ago. That's with a B. And that this happened in an instant. So it happened super quick. Within the first 3 minutes, we had our universe. So if you look at the picture, it's number one is the beginning. It's the super fast explosion. And then the electrons, the neutrons, and protons started forming within the first couple seconds. Like if you look where it says the 1 second mark underneath the Big Bang Theory picture. This is where we still had atoms that were too hot. So they were still buzzing around and smashing into each other and causing little tiny fires to happen. But within the first 3 minutes, we start to get electrons forming into hydrogen atoms, new helium atoms starting to form, and it just looks like this big soupy fog. So if you've ever been driving out at night and it's super dark and you see that kind of like creepy fog, that's what our universe started out to be. Within the first 300,000 years, we started actually getting light. So the fires that were igniting from the atoms smashing together started to create light. Now this is all the theory because we can't go back in time and look at it. Within the first billion years, we started to get giant clouds that would later become galaxies. If you look at the top of the picture, it says proto-galaxy. That means a very beginning rough galaxy. And then within 15 billion years, we had galaxy clusters that were pulled together through gravity. And the first stars started to happen. So let's look at what this all means. Background radiation is one of the links that helps support this. And the background radiation is the energy that's left over from that initial explosion. It's spread out evenly throughout the universe. And because it's all the way through our universe and there's no one spot where it's not there, this helps scientists believe that by looking at this and it being constant throughout the entire universe, that we can say, well, it had to all come from one spot. The picture, the blue one, is in the center. It's kind of a greeny color. Is the radio radiation. And the gamma rays, if you look to the left, are the red kind of pinkish color. And you can kind of see how they're distributed. The dark blue and yellow in the center picture are actually microwave radiation. So because they can use those giant radio telescopes that you guys looked at a couple weeks ago, they can see that it's constant, and based on its the fact that it's the same levels almost through the entire universe tells us that it was a pretty solid explosion. This is the microwave radiation mapped in our universe. The center part is where most of the galaxies are located. And we're going to look at in a second that the older galaxies, the older things, are out towards the center, or out towards the outside. So if you look at kind of the pinkish colors, those are going to be the older galaxies. And so the microwave radiation is weaker out there. So after the Big Bang, gravity started to pull everything into these clumps, basically big balls of stuff, because everything was racing outwards. Because if you've ever seen an explosion, it's not an implosion where it all comes inside. This is an explosion, so it all exits and goes outwards. These clumps were pulled by gravity into these bigger clusters of matter, and that's just a science word for saying stuff. These galaxies would be formed out of these big clusters of matter, and create our universe. So after the explosion, the galaxies seem to be moving away from Earth. Now, Earth is our focal point, so everything that we look at is moving away from us. So if everything is moving at a constant speed away from us, then we can kind of see that it's spreading out. So if you've ever poured milk or water on a table and it kind of spreads out evenly, there's not really a center point, but it all just kind of spreads out because it's trying to find the most neutral place to be. If you look at the second bullet, it says that the galaxies that are moving away from us seem to be giving off a red light. And the things that move towards us tend to give off a blue light. This is that red shift and blue shift that were your vocab words for last week, and I think again this week. So if we look at the picture on the top right-hand corner, red objects tend to look more red as they move away from us. An object that has kind of a blue color to it, if it moves towards us, that's where we get that blue color. If you look at the visible light spectrum, the Roy G. Biv, the red has a longer wavelength and the blue has a shorter wavelength. So that's the picture on the right at the bottom. We can tell that these galaxies are moving because of their hue, their kind of color. It almost looks like a halo as they move towards us or away from us, using those radio telescopes and then also using those reflective telescopes that you guys looked at. So another visual, if you can imagine, the yellow part is the star and the little green part is a planet that most of the time we can't see. But the picture shows that a blue shift, we see an increase of wavelength because the wavelengths are coming closer. They're getting closer together because they're moving closer towards us. The red wavelengths get farther away because they're starting to spread out because we're the positional point, the point of reference, and so everything that moves away from us, it tends to look longer in wavelength. Our expanding universe. If this theory is true, mind you, it's just a theory, then the universe is expanding, and the objects near the edges of the universe are the oldest. So if you think back to the bubble, the things farthest away from the center are going to be the oldest, and the objects nearer the center are going to be the younger. The most distant object from us is 12 billion light years away from us. So that means it takes 12 billion years for the light to reach us. So the visual, you have at the bottom where it says singularity, that's the bang. From the Big Bang, then we had masses of matter and clumps of matter that started to get formed together. Then over a couple billion years, we get a defined galaxy. And now, the top picture, we see that the galaxies are actually moving farther away from each other. So the support for this theory is that there's a presence of background radiation, which is that radiation of micro radio and gamma radiation that's consistent throughout the universe. And then the observation that galaxies are moving from a center point in the universe. So these are our two support things. A theory versus a law. So this is where we get into some wordplay. A theory summarizes a hypothesis that has been supported and with repeated testing seems to be valid. There are no things that concretely prove it wrong. So there's no way to say that this is wrong and then you have proof, like visual or tangible, touchable proof. So a theory is just the most accepted answer that has the best science backing it. A law is generalized body observations. At the time that it's made, there are no expectations have been found as a law. The scientific law explains things and doesn't describe things. A law can be proven time and time and time again, and they can't disprove it. So like the law of gravity. It's not a theory of gravity, it's the law of gravity. If I jump up, I'm going to fall back down. So the theory with space, especially with space, because we don't have proof, we can't make a time machine and go back, so we have to use our science to prove as much as we can, and then it's either supported by the scientific community or it's not. So the Big Bang Theory is our most accepted theory of how the universe began. So at this point, we're going to stop with the video, or the slideshow. And you guys are going to do the next activity, which is picking up the article at the front on the green, next to the green cart on the table. And it says Galaxies, and it's a little book that I made for you guys. I know that this is a big thing to start the week with. I will be back tomorrow, I promise. I will be back by 4 o'clock today, so if you want to stay for tutoring and rehash this or talk about it some more, feel free to sign up on the back, and I will help you. Tomorrow we're going to kind of walk through your notes really, really quick, and then we're going to do a couple stations, and we're going to do something kind of fun. So hopefully the rest of your day goes amazing. I look forward to hearing from you, so have a good day.